Welcome to a new episode of Guaire Dev streaming. Today we're going to create a very special type of artificial intelligence or a neural network. It's a generative adversarial network. It's a couple of neural networks, two neural networks that are able to compete between each other in order to improve their performance. And how do they do that? Well, let me explain it. What we are basically doing right now, or what we did in the last AI episode, was our first stream, was that we created an artificial intelligence that was able to read messages. Let me delete this. Oops. That was able to detect which kind of messages we were feeding it, if it were from a left-leaning political spectrum or a right-leaning political spectrum. Yes, we can add this. And basically, when we added words here, for example, hello, or well, hi, how are you, right? If we feed these words into the AI would be able to tell us if it was right or left. So this turned on or this turned on, right? Right now, what we are going to do is we are not going to analyze the words, but we are going to generate it. We're going to flip completely our neural network. We're going to transform our output into an input and our input into an output. Basically, we're going to tell the AI to generate a right-leaning message or a left-leaning message with a random generator. We're going to randomly generate it. So let me draw it so you can see basically what we're going to do. Maybe make this bigger. Okay, so our generator, let me write it with a prettier font. Right, generator. Our generator is going to be a neural network which is going to have only two inputs, which are going to mean right or left. Let me use this color, blue. Right, left. Yes, that's better. So we add either a right number or a left number. So basically we turn this into a 0 and this one into a 1. Or the other way around, this one into a 1 and this one into a 0. And we are going to feed it to the neural network this way. Okay, let me draw it. So we have a neuron over here, an input neuron, a second input neuron over here, and we're going to start expanding the amount of neurons so we can generate very long words. So these are going to be randomly generated. So when this right here starts making the connections, running all the equations, it's going to output a random word. The words are going to be without much sense. It's going to be, for example, night, hello, world, word is fine, yellow, oh, whoops, yellow, A, for example. So it's going to make random words that are going to be constructed into sentence, right? And when we train this neuron, this network, sorry, this neural network, we are going to use existing sentences. For example, we put a sentence here, and in the left side of the, or in the input side of the neural network, we're going to say if it's right or left. So at the beginning, it's not going to be good. It's going to be like gibberish. Those sentences are not going to make much sense. But then we're going to use real sentences, right? A list of sentences. One here, two here, three here, four here, which we are going to compare in a new neural network. So basically, we're going to have a new neural network over here, which is going to be called the discriminator. This discriminator is going to discriminate between real words, the real sentences over here. We're going to differentiate it with these fake sentences, these generated sentences. So this is going to be named the discriminator. Let me make this bigger. Which size is this one? 170. Let's make this 170 as well. So this discriminator is going to filter and tell us which words are real, taken from Twitter, and which ones are fake, which are these generated ones that at first are going to be really bad, really not much sense. But I'm going to put fake. Oops. Fake sentences. So we are going to feed those into a AI, right? These ones over here too as well. And this discriminator is going to tell us two things: real or fake. Let's put two colors over here, one red and one green. So the green is the real ones, and of course the red ones are the generated ones, which are fake. Not too little, too small. Thank you, Cassandra. Thank you very much. I'm looking at the chat right now. I'm not accustomed to it, but I will try to answer all your questions. The last episodes, sadly, I wasn't enabling the chat because you need to have 1 month of subscription time to me to be able to write in the chat. But right now I disabled that, so if you have any questions, let me know. I will be reading the chat. And thank you, Cassandra. Okay. So these ones are real, right? And these ones over here are going to be the fake ones. That's what basically we're going to do. So let's start. We're going to start with the generator. We're going to transform our detector. We had a categorization neural network that was able to detect between left or right comments, and right now we're going to flip that neural network. We're going to transform the input into an output and the output into an input. After that, we're going to generate fake sentences. These fake sentences are going to be compared with the real sentences with the discriminator. After that, we can iterate. We can generate, we're going to generate fake sentences, and we are going to discriminate only real ones. We're going to get a lot of real or what the discriminator considers real, which are not really real. We are fooling the discriminator, and with these new sentences, we're going to create another iteration, but this time we're going to use the real sentences as fake sentences. So we will compare real sentences with real generated sentences, which the discriminator considers real. But when we tell them, no, these are not real, look, those are generated, and these are the real ones, what happens with the discriminator? We make it better, because we're telling them that what he considers real is in reality generated sentences, are in reality generated sentences. So that way we're going to iterate several times, and it's going to become really good at generating readable sentences that are not randomly organized. The words sometimes make sense. We are going to use a very simple training data, so it's not going to be like ChatGPT, not at all. It's going to be just small sentences. ChatGPT is way more complex and generates incredible text with a lot of information, bullet points, tips. It's really good. And I can also show you something I was testing this week. That is when we use ChatGPT to train our neural networks. It's really nice. ChatGPT is able to generate sentences for you. You can tell them, for example, generate horoscope sentences for my horoscope AI, and it's going to generate it. It takes a bit of time, but it can make a lot of sentences. ChatGPT says it can generate infinite sentences. I can test that. Okay, let's start. Let's change our AI. This is the project we were working on. It's currently uploaded into GitHub. In there you can see this file right here called training resource. In this file, when we try to train our neural network, we are using the input as a long chain of words. For example, this input size is over here, has 100 neurons, so you can insert 100 words. So we're going to change this, and we're going to swap it. We're going to transform this into 2, and we're going to transform this into 100. So we're going to have only 2 neurons in the input side and 100 neurons in the output side. And of course we have to change this. I'm going to change this into an asterisk so we can multiply instead of dividing. And it's fine. Let me see. So when we begin the training, this is the part where we build our neural network. So to explain this to you, basically we're saying we're going to add input size neurons. So this is the input layer with only 2 neurons. This one is the part with 4 neurons. This is going to be 6 neurons. This is going to be 8 neurons. And in this part we're going to have 100 divided by 3. Then 100 divided by 2. And finally 100. So it's going to be 150 and 33, because you can't have 33.5 neurons, so only 33. Okay, so how we saw in our first episode, this is when we connect the layers between each other. And in this part we say this is the input neuron or the input layer, this is the output layer. We say this is a multi-layer perceptron as well. We also in this part we're going to swap our way in which we insert the data in our AI. So we're going to say this instead of input and result, we're going to say result and input. The good thing is that we don't have to change much, just swap these values and it's going to show us the information. For the purpose of this streaming session, I'm going to lower the backpropagation iterations, which is going to repeat the training. So I'm going to add a lower number so it's faster, so we can show it quicker. If we need to make a better training session, I'm going to increase it a bit. So we're going to use backpropagation with this amount of iterations. When we start the training, this is too small, so let me put it bigger. Let me view. Increase. Okay, there it is. Alt-Shift+. Alt-Shift-Point. Oh my. Alt-Shift-Point. Excellent. Can you see the words this way better? Okay. If you have any question in the chat, let me know. Okay. So basically, in this part over here, we save the neural network into a file, and in the end we return the value. So let me restart the project, and while it restarts I will, well, yes, it's fine. Let's check it out in the page. Okay, here it is. Let's begin. It's localhost. I had a previous training, so I'm going to delete everything from the database, so we start from scratch. pgadmin. This is a PostgreSQL database, pretty easy to use, very nice, secure and fast. I like it a lot. And it's SQL. I like SQL. I have used NoSQL in the past, or NoSQL, how most of the people pronounce the SQL word. I use SQL, I don't know why, but I hear everyone always saying SQL. I didn't know why, but sometimes I say it like that. Okay, so let's truncate everything, so we can start from scratch and delete everything from the database. All right. Okay. So, what? It's not deleted. Oh, this is another one. It's another project I was doing. I shouldn't have deleted that, but oh well. It's this one. Perfect. Let me see if I can truncate. Delete. Awesome. So I added some instruction over here if you don't know how to train the AI. At first, we have to upload the left-leaning messages, and after that, the right-leaning messages. So let's do it. And we also are able to upload the words file over here. As you can see, there are some instructions over here. In this file, we insert the messages. We're going to start with the left-leaning messages. We say over here that it is from the left. And we add here the words. We have a words file over here. This is a new one. I will be able to upload it to the GitHub account or the GitHub repository, and it contains 10,000 words. I started seeing, well, while we save this, I can explain it to you. Here it is. These are all the words that are being saved. Getting back into what I was explaining, at first we had like 200 words or something like that, a small amount of words, and when I increased the amount of words, the AI started to become a bit unstable. So after adding that amount of words, I also ordered them by number of appearances in the Twitter messages. So each sentence, for each of the sentences, I counted how many times each word from the database appeared. So it was very interesting as well, because when I saw the database and how many words appeared, or how many times each word appears, I started to see that the word THE was the most used, and it makes sense because that word appears a lot. This is the most used word in the English language, and I ordered it not in the database, but I added the number 1 to the word the as a reference. So when I add that word to the neural network, I just add the number 1, and the second word I think was A, the letter A, and the letter A was the number 2. So the number 2 is what I fed to the neural network, etc. So that way, when ordered and neat, the AI was able to detect each word better. It was really nice. So I will try that, not at first, not at the beginning, but after we finish the generator. Alright, let's add the right-leaning messages. from the right. And it was quicker because I didn't have to add the words. And finally, in here we train. Let's see if it works. It failed. Let me see why. If you are running a project and it fails, don't worry. That's something we as developers see most of the time. Bugs and errors are something that happen because we are human and we are not perfect. But we are really good at improving the things we create. We humans, I think, are the best living organisms that can improve our creations the way we do. It's really impressive. So what was the bug over here? Null. Input is wrong. So let's see the input. Result, ds. Aha, this is the error. As you can see, I had to swap this as well. So this is output size, and this one is input size. Gracias, Carlos. Thank you, Carlos. La Máquina Trading. Okay. Then let's try it again to see if it works. So basically what we did is that we created this generator that instead of having the input side at the left with the sentences, is going to have it as an output. So it's going to output words. And instead of having the output as a right-leaning message of left-leaning message detection, we have an input with the right or left. And we're going to randomly generate right or left messages, which we are going to output a list of sentences. After that, we're going to compare real sentences of from Twitter, and we're going to compare it against these fake sentences in this new AI, or this new neural network that is going to be called the discriminator. This entire diagram here represents an AI that is comprised of 2 neural networks. Perfect. Let's try it to see if it works. And it gave us another bug, another crash or exception. Exceptions don't crash your system, but they are not really really nice to have. Input vector size does not match output network dimension. Let me see here where I declare this. Oh no, it's wrong. It's wrong, sorry. I don't have to swap that. My bad. This is right, because I already changed the number at the top. So I don't know why I changed it again, so my bad. This is going to be input. This is correct. Input and output. Those are the kinds of mistakes a human like me, which is not perfect, can have. Oops. And let's start it again. Right now it should be working no problem. Result. Okay, right now it's training. So in this output over here that I added, it's going to transform the words into the numbers, so the AI is able to read them, because the AI can only read numbers. Training was successful. So let's check this out over here. Perfect. So we are going to generate random messages using that AI. So how do we do that? Let's do this. Right now, in this generator, you have that already in the GitHub repository. Right now, basically what we're doing is we're getting the training from here. Oh no, sorry. Yes, we're adding the training here just to say if a word is right or left. If we generate it. But in this function, we are not generating it using a neural network. We are just generating random words, and I did it in an array without any without making much sense. Right now we're going to use the AI, and with that we are going to be able to generate words by saying if they are going to be left or right. So let's do that. Okay. So the input is going to be this. The sentence length, I was creating only 25 word sentences, so that way we were able to do this faster. Maybe I will increase it a bit, but for now I'm going to leave it at 25 because I think it's going to be a good number. So yes, let's do that. Let me delete all this and start from scratch. Where is the neural network? Here it is. Okay. So I have a random, I think I have a random, here it is. Random, this is a random number generator that's going to be able to give us randomly generated numbers, so we can create random inputs for the AI. So we're going to copy this and delete the rest. Basically, we're going to generate two numbers. Int, I don't know, random number. Oops. Int random number equals that, right? And we're going to only use two numbers. If it's the number 1, it's right leaning. So we're going to create int right leaning, int left leaning, and if the random number equals 1, right leaning is going to be 1. And if random number is another thing, left leaning equals 1, 2. Right? So we're saying Oh no, let me see. I think this AI is different. I think this AI, oh no, yes, it's okay. So this one is the left, because this is an array of only 2 numbers, and we're saying the same thing we're saying in the condition below. So we're saying left is 1 at the first placement of the input layer, and right is a number 1, so like this. This one okay. So if we add this into our neural network, it's going to generate a right-leaning message. And if we do this, 1 here and 0 here, it's going to generate a left-leaning message. That's basically what we're going to do. We're going to generate left or right, left, randomly. So let's do it. Let's generate the thing. So we're going to say that ANN dot set input is going to be new double. Let me see how I did it in the past. Like this. And I did step by step. This is good to copy. I like to copy the things I do in the... Where was it? Oh, here it is. So I'm going to copy this. Okay. So this is going to be... what's the name of that variable? It's AI input size and AI output size. Perfect. AI input size and AI output size. Ah, it was already here. My bad. Well, no problem. Let me add it up there. It's better. Our input is going to be over here. So input the first space of the input is going to be the left leaning part of the layer, of the input layer, and the input the second position of the input array is going to contain our right-leaning variable. So basically we generate a random number, and then if the number is number 1, we say this is the right-leaning message we're going to generate. And if the I don't know if it's from 0, we shall see. If we see irregularities in the generation, we will be able to see. And in the left-leaning, and if the number is 0 or 2, we're going to say the left-leaning is equals 1, and we add that to our artificial neural network. So we add here input, and to generate the output, we say output. What's the number? No, result equals ANN dot get output. So that way we get our this is going to be a generated sentence. That's not going to make much sense. It's going to be a mess, but no problem. So let's do that. Let's generate words. Okay. Perfect. Sentence length. Ah, right. Perfect. So basically what I'm doing here, I was interpreting my own code. Sometimes it's like hieroglyphs. I'm going to go word by word and getting the number value, or better said, I'm going to get the string word by giving as an input a number. So in the database over here, if we see the words, we have all these words over here. I can zoom, but all these words have also a value over here. So when I give the number 2, that function is going to give me this word AA. When I give the number 151, it's going to be admissions. So that way I'm able to construct the words for the sentence. So let's do that. Okay. Oh, it's not the input, it's the output. Let's, instead of using result, I'm going to use the word output because I get confused. One of the things I always say to everyone is that we have to use nice names for our variables, because, not nice, but names that express what that variable stores and what it does, and that way we don't get confused. There are conventions and standardizations that use, for example, with this camel case, with starting with the lowercase word, and if you have complex words in your variable, the second word is going to be uppercase, so that way everything looks great, and using the same way to name the variables, and it makes the code easy to read, easy to maintain, and easy to share to your team members, etc. So it's highly recommended. Okay, so finally we build a message object that is going to have our sentence words that we constructed over here. We're going to also say if it's a left-leaning or right-leaning message. Where is this? No, this is not. We can't do that. We can't do this right now because we're not using that AI. So we're going to empty it. So basically, what we're doing here is just generating some sentences. They are not going to necessarily make sense, but we shall see. All right, let's generate a random word. It's empty. Let's see why. Why is it empty? Let's check it out. So we're going to debug, or in debug mode, and we're going to explore the code step by step to see what's wrong with our code. Okay, and here we are. So this is correct. We create a input and an output. Y esto por acá. Oh, I know what's happening. Or no, I don't know what's happening. So the word random number, it's a number 1, as you can see over here. So when it's number 1, it's going to build a right-leaning message. So let's see if it builds something. Let us see over here. And the output is coming out empty for some reason. So maybe our training is not okay. So let's run our our training again to see if we're doing something wrong, because it's not generating anything for some reason. It's an empty sentence. Okay, so let's go to do the training again to see if we are missing something. Let's go to training, delete. We do have files over here, so and we're going to train again. Let's see over here. Before training, I'm going to add a breakpoint. For those who don't know, a breakpoint is where the code stops when we use debug mode running the project. Okay, let's see. Layer, neurons. Okay. So let's see. Let's see if this is adding correctly. The best way to solve errors is debugging. I really like it a lot. Let's see if this is output, giving some output. Oh, this is the error right here. What's this? This is the problem over here. Let's see. I think I'm not getting the value right. Number value. Let's see. Let's see over here. Because I think I'm doing something wrong. Oh, here it is. Where is this? Oh, I understand what happened. It was in another place. My bad. So let's do this again. And it's not stopping. Let me see why. Train. Let's see over here from the beginning. I think we found the error because it's not even entering that place. Okay, so we have 600 messages. That is correct. The input, the output. Okay. An exception. So let's see this over here. See if it at least finds some words or something. Or maybe if I stay here and check the input. Okay, let's check it out. Okay, perfect. Input. Why input is like that? This is wrong. Oh, I see the error over here. This is the error. This is the error over here. I found it. So basically, I wasn't even adding the left or right value to the AI, so right now I'm doing it. So if the message is from the left, we add the number 1 here, and if it's from the right, we add the number over here. So that was the error. So let's start this again. We found the bug. Okay, and let's train our AI again. Let me make this bigger so you can see. Train. Perfect, it was very quick. Awesome. Let me delete the other ones. Delete. Was a very fast training. Wow. Oops, this one not. Okay. Let's generate a random message. Let's see if we can generate messages. Nothing. Still nothing. Let's see if the training is still correct. Because I didn't check that. I didn't check if the training was correct. I just saw the green notification and I assumed that everything was fine. So, okay. Number value. This is not... what? I don't know what's this. No, this is wrong. Let's delete this. This is some legacy stuff that was before we deleted the other thing, so it shouldn't be there. Or... oh, I know what's happening. Yes. Yes. I should use result. This one is the result. This is the output. Sorry, guys. I wasn't feeding the AI with the output, so it generated just empty sentences. So right now, if I tell the AI that the result is going to be the number value from the database, over here we say, oh, they can show it step by step so you can see it. Let's do that. Let me delete this one and train again. Oh. What happened? Well, it's training. It's training. Right now it's training successfully. So it's doing what it should do. Let's see. Still nothing. Let's check our training again. Let us see. Okay, but why doesn't it? Maybe I should start the project again. Maybe it's that. Ah, yes, it's that. I had to compile again. All right. Let's delete this. And let me check it step by step. Oh, that was the error. Okay. Okay. Perfect. So, this is the sentence. As we close out Black History Month, so the first word is as, right? So when we use this function over here to get the value from that word, the word is as, right? AS. And if we go here, we find the word AS over here, 560. So if we do another step in our code, It should be 560. Correct. So that part is right. It's from the left, so this is correct. So the input is 1 and 0, and the output is wrong. No, sorry. The output should be 560, right? Yes, and it's correct, 560. So we are doing this right, the right way. Let's see if we are training correctly as well. So what was that? That was a mistake, you saw? I don't know why it got out of the buckle of the loop. Let's see why. For each word, right? Words. Let's see. Oh, this break over here was the problem, you see? Should be AI output size. That's the problem sometimes when you change the AI. Sometimes the variables, the old variables stay there and give those kinds of weird behaviors, but no problem. That's part of being a developer. Everything, all the times can have small bugs or big bugs, but bugs are everywhere always. That's why the older a system is, the better it is, because you have been fixing it for a long time. Years and years of fixes. Right now it's taking a bit more time, so I think this training is better. Yes, definitely. This training is taking a longer time because it's using correct values from the input and output to train it. So my bad. Sorry about that, guys. But as you can see, if you try hard enough, you can find every bug and make it work. So while it trains, oh well, it finished training, so perfect. Let's generate a message, and it's empty again. Okay. Still empty. Oh my. Or maybe if we increase this size over here, I think it will be better. Over here. Let's see if this works. Maybe there's a mistake over here as well, so I will check that right now. I think the AI is being trained correctly. Maybe I didn't check it in reality. Let me check it. Let me check that. So, okay, this is the training, the results, okay, add row, okay. Let's see if this is correct. Let's make another training. I'm not going to save it. Okay, no, it's correct. It's doing the training the right way because input is right with a 0 and a 1, and the result is also right with all those numbers. Yes, yes. So it's correct. Well, let's do it. Let's do the training again. No problem. Oh, maybe it's because of the iterations. Well, let me add another number 1 over here. Maybe it's too slow. Oh, sorry. It's not this, but this. Debug. Right. Perfect. It's transforming all the words into numbers in each of the sentences, as those numbers into an array, then into the neural network, and finally when it does the training, it's going to take a bit more time because I add another quantity of, or a bigger quantity of iterations for the training, so it's going to take a bit more time, but not so much. In the meantime, I'll be back, so stay tuned. Thank you, Carlos. Thank you very much. AIs are amazing in reality, yes. Be right back. Yes, indeed, Carlos. Learning AI is important for us as developers, and sometimes people tell me that they are scared that an AI is going to take their job. But if you're scared about that, you can maybe become an expert on AIs, right? I can help with that. So if you become someone that can create, maintain, supervise, or manage AIs, maybe then you will be able to survive. But I don't think many AIs are going to take everyone's jobs. Many AIs are going to be used as assistants, mostly because of legal reasons, right? Sometimes AIs can't make decisions that a human should do, for example, or sometimes an AI generates things that need a bit of retouching because AIs always make approximations of what the data they received. Why did I delete this? Sorry, guys. I don't know why did I delete it. Maybe because of a reflex or something. But oh well. Let's train again. Maybe that training wasn't right enough. So let's doing it again. Oh, you're getting a drink. Okay. I didn't read that message. Okay, let's see how it is going. It's doing the training. And in the meantime, I'm going to check the code for the generator. Oh, let me turn my air conditioning on because I'm a bit hot right now. So be right back really quick. I'm back. And yes, I really think that AIs are the future. For example, for this course image, right now, as you can see, these two robots over here are AI generated. So if you need something to make a poster, AIs can help you, and that way you don't even need to think about licensing about those images. They are free to use, of course, because they have no owner. They are randomly generated by an AI, so that's pretty good. Both of these images, from the one in the left and the one in the right, are AI generated. It's pretty cool, right? It's still training. Oh yes, you use a lot of AI. Very nice. And what do you use it for, Carlos? Maybe generating words as well, or images. Code, awesome. It's like an assistant, right? It's pretty cool. It's pretty cool. Awesome. It's very powerful. AIs are awesome, man. So the training is taking a bit longer than expected. Okay, black box. Okay, awesome. I never used it. I'll try it out. Seems kinda nice. It's taking a bit longer than I expected. And in the meantime, I'm going to check the generator to see if our generator is giving any problems. Let me see. If this next training is going to give us a bit of, if it's going to give more problems, then I'm going to try something else, because this configuration right here is not the best one. I've tried last week. I tried another one and it was better. So maybe let me check that out. Oh, it's empty again. Okay, let me see. Let me see if I check this, if we can see where the error is. If we're generating correctly the random words, etc. Okay. Oh, no, it's okay. Oh, okay. Okay, so the input is like that. and the output turns out to be 0. So well, I will try another thing. Instead of using this configuration 0 1 and 1 0, I have found that a better one is 1 1 0 0. So this is going to be, instead of this, right, left, okay. Instead of this, it's going to be 0 0 0 for left, and 1 1 for right. So let's try that. And if it doesn't work, I will order the words, because that's what made it easier the other day. Okay, let's try that again. We have to train again the neural network. That's the bad thing, but maybe if I lower the iterations, it will be fine. Let's lower the iterations. And so, okay, so if left, 0 0, and if right, 1 1. Finally, this is easier like this. So if the random number is 1, we add 1 and 1 for the right, and 0 and 0 for the left. Also, let's instead add here 80 words. Permanently. Maybe that way we force a generation, because 25 words, I think it was too low a number. Okay, this training is going to be faster, thankfully. Oops, not here, but here. Okay, and let's debug again to see. Just a bunch of zeros, 1 1. It should generate a right cleaning message. It's not generating. I don't know why. Why is that? Net. Did I train it? I think I didn't train it. No, I didn't train it. Yes, I didn't train it, my bad. Okay, this one was faster. Let's check it out. Please work. It didn't work. Okay, let's see. Maybe let me check the training again, because this is not working. Oh, okay. Let me try something even weirder. To see what it happens here over here. Let's get a random number from here to a big number. Random number and random number 2. Just testing over here to see if this is going to work out. Okay, random number. Okay. Let me see if this is going to output something. Nothing, still nothing. Let me see what's generating over here. Y00. Why? Oh, my bad. I don't know why I had that. It's like this. That conditional wasn't letting the input to be updated, so let's check it out. Check it out again. Okay. See if it outputs something. Please work. It didn't work. Well, let's not stay over here with this. So I think let me check the training again to see if I'm missing something, or else we're going to just generate random words and share it to the discriminator, and we can proceed, because we can stay with this part for too long. Check this quickly. Okay, input size. Okay. Perfect, this is working fine. 0 or 1. Let me see if this enters here sometimes. It never enters here, you see? Oh, don't tell me our training is wrong. Oops. Maybe our training is wrong. Yes, it's wrong. Oh my. Yes, every message is from the left. Oh no. Right. Then why? Let me try this again. Boom. Training. Oh, it's still training. Let me stop this. Oh, it entered. It entered here. Perfect. So it does get right-leaning messages. It was just taking a long time. Okay. It's taking right leaning messages. Yes, it should be working. Added info. Yeah, it should be working. Added info. I see that it's working fine, but I don't know why it's not outputting anything. We delete this over here. Okay. Train again. Yes, it's adding it. It's adding it well. All right, we're going to create a fake neural network because this is taking me too long. Maybe I'm missing something. Maybe in the neural network properties. But we're going to just randomly generate some words. Let's do that. I'm going to copy the ones from the code in GitHub. We will be able to generate some words to at least use the discriminator. The discriminator is going to be really a good AI. And of course, when I upload this into the GitHub repository, I will upload the correct AI, so you can have it in your tests. Okay, perfect. Okay. We're going to create another AI right now, so no problem. Sorry, what's this? Oh no. This one, generate, perfect. Let's generate some random words. Some random words over here, just like what it was before. You know what? Let's start from scratch. Let me delete everything, because we're not going to use the other AI, so I will start from scratch. Roll back. And we're going to start from scratch. Let's see over here. Sometimes that happens. You have to start from scratch sometimes, from time to time. All right, we're doing the normal training from before to detect left-leaning or right-leaning messages. And after that, we're going to generate left-leaning and right-leaning messages. So we're still using the AI, but the first one, not the generator one. So, well, no problem. In the meantime, I'm going to generate, or I'm going to to create a function that's able to order the words by number of appearance. So that's going to improve our process. Okay, in train, after I add all the words, it's here. All the messages. Words. Where are the words? It's not here. It's way up here. Way up here. When I add the words into the database, here it is. Where is it? Here it is. Save word. After I save all the words, I'm going to order it. Okay. The training is still going, so no problem. We're saving time. So we're going to start here. List words is going to equal word repository dot get all. Find all. Yes. So the words, and when I say also the messages. Oh, sorry. Yes, I need to check the amount of times a word appears in all the messages. Of course, I need the messages to be in the database, so I'm going to do that. Or no, I don't need that in reality. I can add it here instead of looking at the database, right? Yes, let's do it here. Okay, so I'm going to convert all the words. This is the way I order the words, so the AI makes everything better, and the trainings are better, the generations are also better. So this is going to help a lot. So let's do that. So for word in words, all words, word set value, I'm going to set the value to 0. So all the words I initialize it that way, and after that each line, this is better over here. I'm going to initialize this over here outside the loop, right? And for each line I'm going to count the words. It's going to make a split string over here. String split line equals line split space. So this variable over here is going to contain all the words. And string auxiliary word from split line. So I'm going to do a loop over here for each word. I'm going to compare it with the words I have. So if word, I need to make another loop. Okay, let's make another loop for the words. For word in, let me add here this variable better, like sentence word, and this is the dictionary word in words. all words, sorry. Okay, so this is the amount of words in a sentence, and this is the amount of words in the database. If dictionary word appears in the sentence, clean word, sentence word, then word dot value is going to be, well, sorry, word set value. Oh my, oh yes, dictionary word set value going to be dictionary world get value plus 1. So it's going to be the value it had before plus 1. Perfect. Let's try this. Okay. I'm going to need to order that after, sorry, I'm going to need to order the list. So let me see over here. Successful. Okay, let's see if it's working now. Right now it works. Okay. Anna territory street accessible accepted weblogs accessorio Louisiana seeking. So basically this is a primitive neural network that tries to generate random words until something is right or left using the AI, the neural network we trained. So it's a neural network that's filtering random noise. It filters random noise until it generates a right-leaning message or left-leaning message. So it's similar to this, but this is not what we are building. We are building the one turned left side right to the right side. So the input is the output, and the input is still the input, and the output is still the output from the beginning. But we are generating random sentences until something is right or left. So that's what we're doing. So this is the randomly generated word. Advice accepted, abstract, abuse, Abraham, according, activated, accepted, activation. Left and right, so it has the both properties. Left leaning and right leaning. Okay. So now I'm going to do the training to check the ordering of the words. Oh, sorry, this is not what we're supposed to do. We need to add the sentences. So let me delete this here. And we're going to start from scratch, but it's not going to take much time. Oh, it's not running. Perfect. Okay, perfect. Let's create another training. Let me delete the words as well. I need to delete the words. No, I don't need to delete the words, sorry. Let me add a breakpoint. Okay. Let's do this. Right? Take some more, little bit more time right now because it's comparing all the words from the database, etc. Okay. It's not debugging. Well, we can try it again. Let's debug. Stop. So right now it's generating, at least. The past time it wasn't generating. let's delete this. Let's start from scratch. What? Oh, it wasn't. I deleted the breakpoint. Sorry. Good thing we have the output here with the number of words left, so we know we're close. Okay, now it's doing great. Let's see how this is doing over here. Let's check this all words list, and it's wrong. We are seeing over here that all the words have this huge value. I don't know why. So let me check. Maybe I'm doing something wrong over here. Okay, this is better if I split it, because this one is way bigger than the other. When you start seeing mistakes, you start okay. I'm optimizing the code right now. I'm making it better, because the words list is way longer than the sentence words list. So I'm going to run the bigger one first and the smaller one later. So the bigger one, all words. Okay, dictionary word. Understand why it's not working. Well, let's see. Step by step is the best way to fix an error. Let's start again. Okay. It's Florida, the word Florida. So dictionary word equals, what's this? Let's do this expression. False. And why it's entering here if it's false? What? Oh, you see this over here? This is the kind of mistakes that make you lose a bit of time, but debugging, you see, debugging is the only way I was able to check it out step by step. It was just a typo over there with a semicolon there, an extra semicolon. Sometimes it happens. It's not the first time it happens in the world. A good thing we found out. Okay, Let me delete the database because it's taking a long time. Truncate. All right, let's do this. I'm sure this time is going to work fine. And if it doesn't work, well, I have to fix it. What else should I do? All right, let's do this. Oops, I didn't click it. Right. So it's faster, not so much, but a bit faster. Let's see. All words. Everything is empty. Why? Oh, maybe the lowercase, uppercase stuff. Let's see. Yes. Oh no. It's lowercase. And why it's not? Well, let's do step by step. Let me follow my own recommendations. So let's do it step by step. I do want you to see this, how I fix the errors, how I Google, everything. Okay. It never entered here, you see? So we have an error here. Sentence word. Let's check this out. Okay. So this sentence word is we. We does appear in the dictionary world. So maybe if we check this, we will see something. It doesn't work. Why? Oh, result we. Perfect. We. So it's okay. Let me try this. If we equals, let me try this. What we're doing is true, you see? So I don't understand. Maybe the word we isn't in the but it should be. Let me check. Nah, we're going to take too much time. check it out. Which one? We. Yes, should be here. So let's see. And I think it's never going to enter there. Let me check this as well. If dictionary word dot equals a, it's false. And dictionary word is, oh my god, the mistake is so dumb. Sorry guys. Dictionary word dot get name of the word. That's the problem. Debugging, you will always find the errors. Good thing that we found it. Okay. Now it's entering here. Perfect. You see A, and at the end, let's put this here and finish. Was a terrible mistake. My bad. Well, at least we found the solution, right? Okay, so let's see the words. It's the all words. Excellent, now it's perfect. As you can see, the word A appeared 253 times. It's pretty cool. So now we can't save it like that because we need to order it and then add the correct numbers. So let's do that, because we have right now too many words with the value 0. So that way I don't think it's going to work. No, it's not going to work because we are generating sentences that we are going to have that value 0. So let's do it. Let's do it. So to order it, we need to find in Google, using Google, how to order a list. List of objects. It's like this. This way we're going to order it. So what's this? Sure. New comparator, word. All words. We're ordering all the words by the time of appearances. Word. So basically, we are doing an ordering function for this list with all the words. That's going to be this one. This is the function that is going to compare if something is bigger than the other. So how do we do that? We say int result equals 0. Oops. and if o1 dot value is bigger lower than, sorry, value not, get value, then result equals 1. Else if. So we're saying if the value of the object 1 is bigger than the object 2, then result is -1. And finally, result equals 0. If they are equal, right? Equals 0. Perfect. And return result. After that, we still have to do something, but we'll do it now. Let's see, okay, we sorted it, and finally, we're going to save it into the database. Oh, sorry, we're going to assign numbers to all of the words, because no word can have the value 0, because the AI will not understand that word. If every word, or at least a big percentage of the words are 0, it's not going to work. So let's do that. Let's copy this, all the words, okay, dictionary word dot value. Let's make a counter over here. Was 1. Set value and word count plus plus. Oh, this is a double, right? Sorry, it's not a double. And finally, we save it. Word repository, save word. And I think with this, oops, we're able to see the words finally in our database ordered correctly. Let me clean this, truncate, okay, training. Oops. Let's run it, and we will have all our words ordered by times of appearance in all of our messages, and that way the AI is going to understand the words better and build better sentences as well, because the words are ordered in an index form, like in our brain. Sometimes the words we use less are like far away in the memory, but the words that we use more often are closer to our consciousness. So the consciousness can grasp the words easily. It is something like that. So even though we are not using a neural network to generate the words, it's something similar to the brain. Oh, let's see. It's way faster. Okay, let's see the words. Awesome. As you can see, the word A appeared, sorry, it is not like it appeared 5 times, sorry, this is wrong. I have to turn this upside down, so I will change this to, instead of lower than, to bigger than, and this like this. Oh, sorry. And we don't need to redo this. this training, this pre-training, because the words are going to be refreshed again. So, oh no, we have to do it. Let me do it, no problem. Training message, delete, truncate. It's the good thing is it's working fast, so no problem. Let's do this. Oops. New pre-training. Right. Save. Let's check our words. And now it's perfect. As you can see, the word A is almost the last word out of 10,000 words. So this way, the AI is going to be better. Let's try the generation, and I think the generation is going to be better. Oh no, it isn't. Let's see what happened over here. The file is empty. Maybe I'm not saving the file. Oh, I haven't trained the AI. I need to train the AI, sorry. Let us train the AI. We can't generate words without the neural network, so let's use it. This is from the left. Okay, perfect. Excellent. And now we're going to train. And this training is going to be way better thanks to the order of the words. And we're going to test the training. It's going to be better. And in the meantime, what should we do now? Okay, let's build the famous discriminator. We're going to create another neural network very similar to this one. And it's going to be called discriminator. So we're going to create now this part over here, the discriminator. That's going to tell if a sentence is real or is it fake. Let's see over here, still training. So perfect. While it trains, I'll do this. So while it trains, we're going to train the AI that's going to be responsible of discriminating between generated sentences or real sentences. So fake versus real. Let's do that. So where did I paste it? I don't know. It's over here, perfect. Huh? Oh, I haven't pasted it. Oh, okay, now it is. We're going to call this train discriminator. Right. It's going to have the same input size and output size. And what we are going to do now, the word generation we created, we're going to use it this generate is going to be the thing we will use to generate words, to generate random words. So let's do that. Let's copy this and create another function called generate random sentence is going to be called. Generate random sentences. Okay, this is going to be only a string. Generate random sentence string. Awesome, it worked. Let's see if we can generate words now. Awesome. Amazon AdWord Framework, Adipex, Addition, Affiliates, Fillings, Admissions, Miscellaneous, Cook Agent, Yours Agent, ADA, Facility. From the left. This is from the right. Afternoon Administrative, Adidas, Adjacent, Chronic, Affiliated, Adjacent, Adding Admission, Fix, Aerial, Adaptive, Advocate, Adequate. And this is for the right-leaning message. And let's try to copy, let's try a new message, a random message to see. This is a right-leaning message because I love the First Amendment and Jesus. Yes, it's from the right, you see? This neural network is kind of nice, I like it. Let's generate another one. This is a left-leaning message. We defend the rights and we are liberal. Let's see. And from the left, how cool is that? You see? This AI is pretty cool. I really like it. It's pretty cool. And let's see if it generates. Sorry, if we add some words like here, like word. It says neutral. No, it says from the right. Let me see another. For example. It says from the right. It has a bias, so this neural network has a bias to the right. We can fix that with better data and a better training, both things. So it's more accurate. But as you can see, it's differentiating between left-wing messages and right-wing messages. And when we generate as well, it can discern between different kinds of messages from the left. Okay, so let's do the famous discriminator over here, and this generation is going to be way better. It's going to be incredible. It will look like almost a person writing. Not as much as ChatGPT. It's going to be still sounding like gibberish or random words, but it makes a bit of sense. You will see. Okay. Let's generate random sentences using this. Okay, input with sentence. We just need to return this. So this function is doing the same thing as this button over here, but instead of printing it over here, I'm going to feed a neural network with thousands of words. Well, 600, just the same amount of words as the as the data we have for training, so we don't have a bias between real sentences and fake sentences, right? So this is the good part. We're now in the cool part and exciting part of this project and this chapter. Okay, perfect. So right now over here in this in this function we called train discriminator, I think. Train discriminator, here it is. In this function we call train discriminator, we created the same thing as the training we did to discern between left or right, right? But instead of using the messages from Twitter, we're going to use randomly generated messages from the function we just created to generate random words. So let's do this. We have the words, we have the message. So instead of using these messages right now, we're going to use it, but not right now. We are going to, awesome, this is so cool. This is okay, but at the top we're going to add the fake words. So we're going to do this 600 times. E 600 E++. Oops. What we're basically doing is populating a list of words into a list, so we can add it to the training data, so the discriminator can compare fake words against real words. So let's do that. This part is the coolest one. So let's create a list called fake words list. It's going to have fake words, of course. Generate random sentence. You see? So we are adding into this fake words list all the random sentences we need, and we need 600. After that, we have to copy this, because this is the part where we add the training data to the neural network, but instead of messages, we're going to use fake words. So we're going to use string fake word, or fake sentence, sorry, fake sentences. Fake sentences sounds better. String fake message from fake sentences. Well, fake sentence. Fake sentence, right? This is fine, okay. Let's count. Transforming fake sentence. It's going to be fake sentence dot split. So right now I need to understand. Oh no, we don't need left or right, sorry, we don't need that. We are just saying if a word is fake, we are going to add zeros over here. 0. But if a word is real, we're going to add a 1. So since this is fake, I will just add this over here. And in here, I'm going to add 1s, because it's a real word, a real sentence. I think we're fine over here. And another thing we have to do is save this file with using another number. We're going to use fake net. Oh no, discriminator net. Discriminator net. So we don't overwrite the other training, the other AI. We just save another one. Perfect. And at the end, let's see one thing over here. Okay. Okay. Perfect. We're going to train the discriminator. We're going to train the discriminator right after we finish the normal training. Discriminator. Oh, let's run it. I think it's going to work, but as always, we have some bugs or problems. It always happens. So let's train. And also I'm going to lower the amount of iterations, because right now it's taking too long, so let's do this faster. For now, just for the test. If it takes too long, it's not good. We're doing a speed run, an AI speed run. Okay. It worked. How cool is that? Oh, also I need to save it over here. Sorry, my bad. Good thing the trainings are fast, so no problem. So the second one. I wonder what's so long. What's so. Oh, it's not here. It shouldn't be here. My bad. So this train discriminator should be, oops, where it's trained after that. And I'm going to add the previous training so we don't override it, and we just save it into the same. We're going to add this file over here for the training and this file over here for the discriminator. So that's what I'm going to do. Training. Okay, so we need to add this. Train dot, it's just this one. Now it's fine. Transforming the first sentences. This is the normal training, and in this part we have the generation of the random words. So this 001, where is this? Maybe this training is not good. Let me add at least more iterations because I think it's too bad. Let me add at least 4. I trained it well. Perfect. It's working fine, so no problem. Right now it's training the discriminator and it's successful. Perfect. So let's see. These files over here, and it's perfect. Now here, instead of generating like this, we're going to generate only words that are using the discriminator. So let's do it. How do we do that? Let's go to generate, and in here we're going to use 2 neural networks. We're going to use the initial neural network. Those are going to be the adversaries. The first neural network is going to generate left or right messages, and the second one is going to see if it's fake or real, comparing it, or using the training use, comparing real or fake sentences. So let's do this. I will use different variables just in case. File 2 is 2. Did I copy it 3 times? Yes, my bad. You just need 2, not 3. FO2, FOS2, FOS2, NN2. This is one discriminator net. Right, so now we are using 2 neural networks. This is a deep learning AI, and we are going to use it here. So, okay, I'm going to delete this, I'm going to delete this and this. and now we are going to train it. So we're going to do this, en2 punto calculate, and we're going to add, oh sorry, input, the output. What's the input? Oh no, sorry, the input are the words. Sorry. Input. Sorry. ANN2.set input. And this is going to tell us if a word is real or fake. So we're going to use a double word 2. Oh, sorry, get output, my bad. I don't know what I'm doing over here. Calculate and then get output. 2. So, as you remember, the output should be 1 and 1. So, if network output 2 0 equals 1 and dot 1 equals 1, then this means we found a real sentence. So the AI thinks it's real. At least we fooled the AI. But after this, we're going to iterate the AI so it gets better. How we do that? You will see. We will use sentences that the AI thinks are real, or better, yes, sentences that the AI thinks are real, but in reality are fake. So are going to be generated sentences that the AI can process and think are real. We're going to generate 600 of those that are real, but then we are going to use this same neural network, this discriminator, and we are going to tell it, look, the ones you thought were real are fake, because these are real. So we show them the real messages, and the ones the AI thinks are real. And we're going to compare it. We say these are fake, that you think are real, and these are real. And when the AI trains with things that the AI thinks are real, it gets pretty good. It gets way better. So let's do it. Good sentence found. Perfect. Let's do this. So as you can see, the first sentences we created were not that good. Were kind of weird. But these ones are going to be better. Okay. Let's generate a random message. As you can see, it's training over here. Maybe I should train better because this is difficult generating. Okay, it's generating something. They have to fix it. I don't know what this. Okay, advertisement essay, aerospace, ADSL, additions, agent, expires, adjustment, addresses, viewer, adding, Adelaide agreement, and afternoon ASL adware. What's that? I don't know. Okay. I'm going to improve this by adding something that we use when we speak. Let me check this because it's taking too long to to create the sentence. It took a long time because of the training, of course, but took a long time. System out. Okay, perfect. Let's make a better training. And in the meantime, we're going to do something that's going to improve our word generation. Let's make a better training. And I think this training is going to take a long time, but we will be doing something else in the meantime. This one is the one that it should be. See, oh, sorry. It's generating fake. As you can see, fake until it gets 1 and 1, and it prints the word. So it takes a long time. So we can do a better training because it's taking too much time. Let me stop this. And let's do another training that is going to be better. Okay, training. Let's delete this. And this is going to take a lot of time, but let's do it. I'm going to do something to create a better sentence, a better fake sentence. So let's do it here in generate random sentence. Okay, and instead of here, I'm going to fix that better. Okay, I'm going to use a number from 1 to 10, right? Int word type is going to be called. Oh, it's already here. Wow. So why is it not working like it should? Sorry. Oh, this is the mistake, of course. This shouldn't be like that. Let's do this again. This should be a number like 2 or 3, not like that. So let's delete everything. Let's start from scratch because this is not how it should be. Oops. The words are not being ordered correctly, so I have to fix that. And maybe it will be better. You will see. Okay. On the right. Didn't order the words. Oh, because I didn't add the words, sorry. Training. Truncate. Truncate. Alright, let's start from scratch. So here, okay. Training. Twitter feed. This is the words file. Now it's going to take a long more time. We are saving the words now, and after that we're going to order them, and then we will do the training. So let's see if it does it in the right way. I don't know. The good thing is we only need to do this once, so no problem. Awesome. Now it's saving the sentences. After that it will order everything. Hopefully gives no problems. Let's check this. Oh, so it's backwards. Or it's right. I think it's right. Let's make it backwards. So I don't know why. So let's make this backwards. It was working before. I don't know what's the problem. Let's do it again. One message. Truncate everything. When in doubt, truncate everything. Well, don't follow that. Don't listen to me. Okay. From the left, let's add the words. I'm going to save the words again. Those are 10,000 words. ChatGPT has 50,000 words in its dictionary. So, and not only that, it has many more things that are way more complex than this AI, but they are similar in the way they read words, and not so much in the way we output things, but at least we are generating some random sentences. It's almost there. Perfect. Saved. Let's see if this is correct. And it's correct. Perfect. This is just what I want. Okay, now we're going to add the other right linear messages. This one is not going to say the word, so it's going to be faster. Way faster. And it's great. Perfect. And let's do the training. Let's go. So I think it's going to take a while, but no problem. In the meantime, I will be back. Let me get some water and a bathroom break, and see you soon. Stay tuned. Okay, I'm back. So it's doing the training. It's doing now the discriminator training. So let's see how much time it takes. I don't think it will take too long, but because there are not many sentences, but I think it's going to be taking a bit of time. So after this, we are now able to create random sentences using our AI just to detect if those are right or left-leaning messages. And after that, we are comparing it to the discriminator, and if the discriminator detects that we have a real sentence, not fake, then it returns the value, it returns the sentence, only if it seems real. After that, we're going to iterate. It's going to be awesome. I'm going to fix this generation. Let's make it better. This generate sentence could be better, so let's do it. Let's make it better. Oops. Okay, here it is. Instead of doing all this, we just need to generate. Oh, this is fine. See if this ended. Still training. Okay. We are going to do something else now. We're going to do something very important. So let's start a new file. And this is what I call the discriminator improver. Let's start over here. So how do we improve this generator? Basically, what we're doing is, this is the generator. This is the discriminator. Let's make this pretty here. Okay. Well, let me draw this smaller. We have a generator, a discriminator, and real words. Let me make this better, like this. And let's add some text over here. Oh, sorry, Carlos. They have a lot of inputs to achieve. Yes, they have the input layer is huge, huge, huge. Thank you, Carlos. So we're going to have. This is the first time I stream with the chat on, so sometimes I forget about the chat. Sorry about that. La Máquina Trading. I'm sorry, but yes, I will be paying attention more to the chat window. So we have here real words, real sentences. This is the generator. Generator. What's this? Oh, okay. Thank you, man. Real sentences, and this is the discriminator, right? So this is going to tell if something is real or fake. So we have red, green, and this is cool. This is really cool. You see, this is like a iteration that's going to improve the discriminator. See, sorry. Okay, perfect. Then let me delete this because seems like it's not looking so well. Okay. So basically, what we have right now is this comparator over here that uses real sentences, and let me put this better like this. Okay. And the discriminator tells us if something is real or fake, right? Then we are going to generate words that are in this. So we're going to generate, this is the training process, right? One, it's the first step. The second step is going to be generating lots of real sentences. So we have a random right? So this time we're going to generate this is calculate from this generator. Or yes, we're going to do this like this. Let me see the training over here. It trained successfully. Let me check this out if it's generating better. Takes a long time to generate. It's too slow. Way too slow. Let me see something over here. We're doing something. Well, let me finish the while it calculates. Let me finish this. Okay. Aha. Let me delete this. This part is important. So we're going to generate this is the discriminator. Let me copy this, paste it here. Oops. This is the same discriminator, but here we're training and here we're calculating. So training is the process you do before, and calculating is when you feed the already trained AI to process something, right? So in here we're training, and in here we are calculating and generating an output. Oops. What's this? Nah. Well, this is better, actually. Well, not much. How do I put that back in here? Well, I leave it like that. And this is calculating. And those words that are considered true words or real words. What? Oh my, skip. Over here. The other one's over here, fake. So let me add this here so you can see this is real, fake. Or real. When we are calculating, we are going to trash, dispose, ignore fakes. But the real ones, this is not, those are not real ones. Those in reality are fake real ones. So because they are generated randomly, right here, because they are fake, but the AI thinks they are real, right? So we add those into a list, right? We add a list here. Oops, let me use this better. So we have 1, 2, 3, 4. Add 1. Let me add 4 here as well, so we don't have any problems. Real sentences, right? And we are going to take these ones and use them as training now. So we're going to feed in another training. Let me separate this so you don't get confused. Like this. Sorry. Better if we do this first here and then here. Perfect. So in this part, we're going to train again. This is going to be a second training. Right? And let me explain it here. 3. Sorry. train, oh my, train with generated real versus real. Real. So we still have here the list of sentences, real sentences. Let me delete this so we can make it better. Oh no, it's okay, yes. Right? This is the discriminator again. Let me copy this. And then, of course, it's going to make this again. Let me copy it. Can I copy this? Yes. And then we have another. The good thing about this, if we can iterate. Generate, improve. Oh, sorry. Generate and calculate. So basically we can do this again. I don't have to make another step. We can just go back here again, you see? Again in a loop. Oh no, yes, I need to do another step. Sorry, yes, I need to do it. Because we are going to be calculating, not calculating again. Oops. Calculating 2. Right? So basically we are refining our discriminator. Let's see, background. Let me flip this. Edit, edit, transform. Okay. So this again is the discriminator. Oops, not this one, but this one. And we again are going to, oops, So basically we're going to create new generation of, let me put it like this, again, right, with real sentences again. No, sorry, we're going to test it and we're going to output again let me copy this. Well, let's create this again. Create and add to a list again. So let's copy this. And of course we iterate. So in this step we're going to call the second generation. Okay. Before generate better words or sentences, better sentences, generate better sentences with better discriminator. Right? So all these words again can be fed sorry, to this again. So this is a loop that's going to let us put it here like can't read that. Let me add this better. So the step 3 and 4 can be iterated several times, but of course it takes time. Iterable, is that a word? Iterable. Let me check the dictionary. Iterable. Yes, capable. See, yes, it's a real word. Not that crazy, am I? Okay. So I don't know if you understand this process. If you have any question, let me know, because it was difficult for me to create it, but it's really nice. So let me start from the beginning, and let me make a bigger, like this one. Yes, this looks better. So basically, at first we just use real sentences and fake sentences, right? And we train the discriminator. We tell them which ones are fake and which ones are real. After the training, we have our AI. Our AI is ready to process information and tell us if something is real or fake. In the step 2, we test lots of sentences, and the ones that the AI tells us are real, that in reality are fake, we are going to use in the next training. So when we have these fake sentences that the AI think are real, we're going to feed them to the second training phase, and we were going to tell them the AI, look, those previous sentences you told us were real, in reality they are fake. You see, these, what you think are real, are fake, and these are real, that are these ones. So we are comparing fake sentences that the AI thinks are real with real sentences. So when we finish creating this new improved discriminator, we can generate new, better, fake, real sentences, and after that we can feed it again to the AI. So the AI will improve by its own mistakes. So the AI will see the mistakes of the past to compare it with the real sentences and say, this is wrong, this is wrong, this is wrong, and this is right. So it will improve over time. That's the AI improver, and this is not working, so this is not generating anything. So let's see what's wrong. Let's see in our generation what's wrong. Thank you very much, Carlos. I tried to do that, and it was difficult to me for me to reach that improver, but it's really nice. It's the discriminator improver. Okay. Let's try to generate a random message to see what's wrong over here. Oh, I'm not debugging, sorry. Let's debug. Yes, it takes a long time. Maybe it's because the training is really good, so it takes a long time to create a fake word. You can make another simple training, so it's not that strict, because yes, this is not good. Oh, let me see if I'm making a mistake over here. We're saying 1 and 1. Oh, this is wrong. I don't need this. Oh, I know what I'm doing wrong here. This is wrong. I have to do it better. And oh no, it's better. Yeah. This is the problem, you see? I have to put this over here. ANN2. That's a mistake. Maybe I'm not doing that right in the other part. Let me see. Oh, it's fine. It's fine. Perfect. Yes, that's a mistake. We're doing good. Perfect. Oh, I forgot to debug, sorry. It's here. So I don't know why it's not getting the output as it should. Let's see. Maybe the training is wrong as well. Let me see the training. Train random sentence, okay. What's this? Oh, generate random sentence, not train. What was the name of that function? Train Generate random sentence. It's still a training, but I can't find it. Maybe it's at the top. Train discriminator. Perfect. Okay. Okay. This is the problem, you see? Everything is 0, 0. It shouldn't be like that. No, it's right. Because all of these are fake sentences. Result 0, 0, result 1, 1. Yeah, it should be good. Should be good. What I'm gonna do is to add less, much less iterations, because it takes too much time to improve. Maybe like this. And yes, both of them will be fine. Oh, I don't show. I'm not showing the chat in the window. I don't know how to do that yet. But thanks for the tips and the feedback. Then the next time I will add the chat to the screen too, so you are able to see the chat. Because yes, right now you can only see like that. Oh, sorry. Like this. But no problem. Next time I will make it better. See. Perfect. We're fine, right? Okay. Okay, it's running, and we are going to let's generate to see. No, we have to train. Sorry, let's train. Oh my. Okay. We have to train again. Let's delete this training. Train. This is going to be faster than the other ones. Yes, this is better. Perfect. Right now it's training the AI. After that, the first AI, the categorization AI, and right now it's training the discriminator, 600 words. Maybe good thing is faster than the last version, so it's not going to take much time. I see this better because there are more ones and less zeros. Oh, I know what I'm doing wrong as well. Yes, I forgot about something very important. Oh, no. Sorry, it was right. My bad. It was right. Sorry. I interrupted the training and it was doing it right. I thought I wasn't training with the fake data, but it is because, let's see, train discriminator. Okay, let's train again, and in the meantime I will build this part, the 3 and 4 part, using this. Well, I'm going to calculate the 2, generating real fake sentences, the part 3 and the part 4. In reality, the part 4 is similar to part 2, if you look it like that. Okay, it's building. Perfect. Okay. It's taking a long time. No problem. Okay. So I will copy this. I'm going to call it discriminator improver. Awesome. Now it's training the discriminator, I can see. This training is not going to take long, because it has not many iterations for the backpropagation. So I don't think it's going to take too long. But in the meantime, let's do this discriminator improver. So it's basically the same thing. But here, with the fake sentences, we are not going to add them just like that, but we are going to test them first, and if they are real, by testing it with the AI, we add them to the list. If they are not real, we ignore them and we keep testing. Okay, training was successful, and let's see how it is. Let's generate a random message. Maybe this one is going to be faster. It should stop because it says 1 and 1. Maybe the buckle is wrong. Let me see. Generate all right. Let's see. Well, I don't know what's wrong here. Let me see. Let's stop and rerun. Okay. No problem. Until we get a 1 and 1, it should stop. And the input, why is it so slow? Why is it so little? Only gives 4 words. Sentence length. Oh, this is wrong. Sentence length should change, because or else we're going to make only 4. This time the sentence length was 4, so with only 4 words, and it stood like that for a long time, so I had to change that and add it over here in this loop, and let's add it into 100. Oh, and I know what I have to do. Perfect. So this sentence length is going to be changed each iteration, because this was not given the value it should. Okay, let's try it again. I think this time it should work. I saw one here. Oh, this is another mistake. It should be like this. Yes, it's that. I think it's that the problem. Okay. Still not generating, but why? And I saw one, right? Oh no, still not generating. Wow. Oh, it did. Excellent. Took a long time. Update years. Let's do presidential shit. So shift. Relief wholesale president Adidas termination. I didn't know that bad words over there. Sorry about that, guys. But it takes a long time. It takes a long time to generate. Wow. Maybe I should. Oops. Okay. Maybe we should make this not so big, so with 50 maybe. Maybe 100 is too much. Because wow, it's taking a long time to generate a word. And I have a problem over here as well. Left or right. This isn't a problem here. Okay. The problem is it's taking too long to generate words, so we shall see. I wonder why it takes so long. Totally random words and still nothing. Let us do an easier training because you don't have time for generating for long generations. So let's do an easy training, very, very easy. Like this. Like this. This is going to be fast. Not so good, but it's going to show us the process. So it's training now. Okay, perfect. So if a word has this kind of values, it's not reaching it yet. It's the same problem. Maybe I'm training it wrong. Let me see. Train discriminator. Let's see the discriminator, how it's been training. Let's see over here. Oh, it worked. Perfect. But let me see, because I don't know if this is working. Oh, okay. No, this doesn't mean anything. So I cannot just it's like generating random sentence and a counter. So next time we know in which part of the process are we. Let's check this, generate. Awesome, now it's faster. Perfect. So we're generating just random words. Let's see. Not it need communities on for it fraud. We he get has done. Today you the we do Olympic votes on votes. Originally, if you pointed gaming, now buy more. This have produces. And it's neutral, it's not political. This one is from the left, listen. State was, but Alice, fraud. That Navy now, to across to fraud, not that Republican. A, but he Republicans support. Which president help in news among going Florida? Massive Georgia's milk need from charming. It's from the left, that message. Let's see if we can generate some from the right. Neutral, okay. From the right, ensemble affiliate relief he brat. That's a message supposedly from the right, but this training is not that good, but the word generation is kind of nice. I can see it. Cool. So now what we're going to do is pretty funny, right? We're going to do the improver. So let's do it. Okay, discriminator improver. So basically we have to generate lots of words, and after that over here at the top I'm going to load the neural network. Let me see if I can okay, this is the discriminator neural network. So let's load it over here. Beginning discriminator rover train. Such a big mistake here. This is a big mistake over here, so I have to fix it. Where is it? Oh, sorry, it's generate. So this over here should be 2. I don't know why it worked, but it worked. What? Oh, I had already created that file. Where? Oh, okay. Sorry, I already copied it, so I don't need it again here. Perfect. Sorry, I was repeating the same code again. So the discriminator is already over here. When it's saved. Okay, let me create it. Okay, yeah. Let me do this. Copy here. And paste it over here. Okay. So this is the discriminator net. And what we have to do now is when we generate fake sentences, we're going to add a string fake sentence equals this. And then if, oh well, let's do something first. Oh, we need to add the input. Sorry. Number value, this. I'm transforming the sentences 2 times, but for this time I'm going to accept that mistake, so no problem. Okay. Okay, I'm generating a fake sentence. Generating fake sentence. Generating fake sentence. I. Off. Fake sentences. of 600. Oops. Okay, I get the number value, perfect. Okay. What else I do there? Right. Put count. So I'm basically creating an array with the number values of the random words. And after that, when I have the input, I create the ANN2, okay, which is the discriminator, set input at the input. After that, I'm going to calculate, and after that, the output is going to be similar to the input. Where is it? Here it is. Output. So if output position 0 is a 1 and output position 1 is a 1 as well, then we have a good word that the AI thinks it's not fake and it's real. So in reality it's fake, but the AI thinks it's real. So we're going to add it to the fake sentences list. Fake sentences is a list of what? List of strings, perfect. So I'm going to add this. This is the fake sentence generation that is going to generate only sentences that the AI thinks are real. So I'm going to change this for a do. What? Yeah, I think I'm doing something wrong over here. Oh, right. Yes, I'm doing this right. Okay. Yes, I'm doing something bad over here, so I have to do this. This is the one I use. I should use cont. Cont is the counter that will be adding into the input all the information of the words, all the number values of the words. I have to do while like real word counter is less than 600 or 300. Wasn't it 600 or 300? Oh, 600, right? Int the word counter equals 0. And finally, if we find a sentence, we say that real word counter is +1. Okay, let's try it. Over here, real word counter. I should add it here, so I don't have to do this 2 times. So since these words are fake, we add 0 and 0. And this result is this. Yes, that's basically it. And let's check it out from the beginning. So first, we load the discriminator. This is the creation of the second discriminator. That's going to be the improvement. Then we create the fake sentences over here. We generate a random sentence. We test it into the neural network. Over here, we calculate. We get the output. And if the output is 1 and 1, means we found a real or seemingly real sentence, and we add it to the list. And we say here that they are not real. With this 0, 0, we say no, those are not real, those are fake for the next AI. So the next AI is going to understand better. Okay. And in this part, we are creating the list with real words, with real sentences. So finally, with this, we can call this just right after we train the discriminator. So it's going to be a second training. So here we do the discriminator improver. Okay, let's run it to see if it works. So we're going to delete this training and we're going to train a new one. So we're transforming the sentences. After that, we're going to train the first AI, the left or right AI. After that, it's going to train the discriminator. Oh, random sentence, no. It's not doing this right. Oh, no problem, I can fix it. don't know why it's not working. Oh, well. Okay. It's transforming the sentences. This is the discriminator training. Now it's transforming the normal real sentences right now. And now it's training the discriminator. And I don't know. Okay. Okay, it's now generating the fake sentences. Fine. It's going fine. It's not taking so long. Good thing. But the training maybe takes a bit longer. Let's see. Let us see. What? Oh my. I made a mistake. Oh, of course. No, it's okay. It's no problem. Because I need to see this number, not the other one. So I can improve that a bit, no problem. This is better. So if we stop here and if we check how many sentences are real now, 0. Oh my. So the AI is not finding anything real. Let's see how's the output. The output is huge. Why is that? Wow. The output is huge. Oh, this is the problem. This is the problem. Output size. No. Let me see. I'm not even taking the value, so I don't know. I don't know what I'm doing there. This should be what I did, what I should do. So let's try again. The good thing is not taking so long, the training. Okay. And let me improve this over here quickly. It's okay, perfect. And the other one I don't remember. No problem. Let's do this. Let's see how the generator is working. Oh, I don't have the AI yet, sorry. We don't have the AI, so we have to train to test. Good thing is doing it fast. But I think we are almost over. I think the improver will work soon, and it's going to be fine. Awesome. This is the thing I had to fix, but I don't remember where it is. I don't know why. Okay, it's transforming now. And after that, it's going to train the discriminator. And now it's transforming the real words into numbers. As you may know already, the AI only accepts numbers, not words. So we have to transform the words into numbers. And now we can see it's finding real words. You can see, but it's way slower than before, you see? 5, 6, and so right now it's working. It's going to take a long time. Well, in the meantime, I'll be right back. Let me do a quick bathroom break, get some water, and I'll be back. Okay, I'm back, ladies and gentlemen. So we are a quarter of the way into the end of the training, and in the meantime I'm going to show you some things I've done with ChatGPT for generating training data. So it's pretty cool. Sometimes I need to generate data for training, like the Twitter messages, but the problem with that is that it's very difficult to get clear data. For example, if I need right-leaning messages from a user on Twitter, sometimes his messages are just neutral, right? Sometimes the messages are only an image, for example, but since I'm taking a big bulk of data from a user and I'm not cleaning that data, the training is not going to be good. So with ChatGPT, we can generate clean data. For example, dear friend, can you create training data for my AI? Interesting. Certainly. To create training data for your AI, I would need some information on the type of AI you're building and what kind of data you're looking for. Here are some questions that could help me get a better idea of what you need. What kind of AI are you building? Is it natural language processing model, a computer vision model, or something else entirely? You see, very important. ChatGPT is so awesome, man. What is the goal of your AI? What problem is it solving? Or what task is it performing? What type of data do you need? Do you have any specific requirements or preference for the data? Do you have any existing data that you would like me to use? Awesome. So let's ask ChatGPT the following. Can you generate a list of sentences for AI training? Sure. I can generate a list of sentences for AI training. Here are some examples. You see, pretty nice. For classification. These sentences are commonly used for natural language processing tasks such as text classification, sentiment analysis, language translation, and more. However, depending on the specific tasks you have in mind, you may need a different set of sentences. Let me know if you have any specific requirements. So let's try this. Give me a list of positive reinforcement sentences for AI training. Reinforcement. Reinforcement. Oh, sorry. Reinforcement. Let's see. Sure. Here are some examples. Great job. You're making progress. Well done. Keep up the good work. You're doing fantastic. Keep it up. It's pretty nice to generate someone that keeps your spirits up. So let me ask Jeremy. Okay. 10 is too little, right? So let's see if we can give me a list of 50. Let me see if we can build 50. So it's able to do it. It's awesome. And for training, it's really good. So I maybe generate 50 like that, 50 with other parameters like negative reinforcement, and you can classify then after that using ChatGPT. It's pretty cool. Let us see over here. Well, it's halfway there. We're fine. We're doing great. What is stood in 300? Okay, perfect. It's improving. So this training takes a long time because it's generating words, testing if they are fake or real, and most of them are fake. So it tries several times, as you can see. This 314, it tried a lot of time. You see 314, still nothing, and then it found a good word, and it proceeded with the rest. So there it goes. This is awesome, you see. Now let's ask for negative. Oops, sorry. Of negative reinforcement. It gave this tip. As an AI, negative reinforcement should be used sparingly and carefully to avoid negative impact on its development. However, if you still require a list of negative reinforcement sentences for AI training, here are some examples. Again, it is important to note that negative reinforcement should be used carefully and sparingly, and positive reinforcement should be the primary focus for training an AI. Negative reinforcement may have unintended consequences, such as discouraging the AI or lowering its confidence, and could have negative impact on its performance. Well, we're not going to use these words to tell something to an AI that if it's doing good or bad. What our plan is to train the AI to discern if a sentence is positive or negative reinforcement. But maybe ChatGPT thinks we are using it to tell something to an AI, but that's not the case. Let's see if we can generate something else. Give me a list of horoscope. Since I am going to make a random horoscope generator, I want to test this. This is so awesome, man. Imagine an AI that can tell you your horoscope, esoteric AI. This is cool. This is really cool. So you can use this, and it's not stopping. So maybe it will give a lot of information. I like that. I really like that. So to train this, what my plan is I'm going to give this kind of words, of sentences, sorry, as a training data, and I will tell the AI that these are able to use in a horoscope environment or plan. And I'm going to give the AI non-horoscope sentences, like political sentences, nature, or something that's not horoscope related. And yeah, I think this should work. I will try it. It's pretty nice. It's like all start with you. Most of them start with you, and they focus on a person and what's going to happen. So the AI may be able to understand that, not the meaning, but the word usage patterns, which words are mostly used in the horoscope but not in normal sentences, things like that. Maybe it's possible. See over here, 450. We are 150 left. It's almost there. The training takes more time, but we'll be there soon. What else can we ask ChatGPT? as a right-leaning political figure. Okay. I'm sorry, I cannot fulfill that request, as generating content that promotes a specific political leaning goes against the principles of impartiality and neutrality that I adhere as an AI. I adhere to as an AI language model. As an AI, my goal is to provide unbiased and informative responses that do not promote any particular political ideology or agenda. My purpose is to assist users in generating content that is useful and informative without taking any political position. Thank you, ChatGPT. I am glad you are impartial. But sometimes we like to experiment with those kind of messages, using it for good, of course. As I have told you before, I like to create AIs and share the knowledge, but I also recommend that you use it for good and for the improvement of humanity. As you can see, these great creations are really awesome, impressive, and if we use it for good, we can make humanity a better place, our world a better place, and humanity also dignified with our positive creations for this world, improve our lives for our children in the future as well. I wonder what our children will use in the future as technology improves, how the AIs will be in the future. I'm impressed right now with what has been accomplished by humanity, and in the future I think it's going to be even more impressive. So wow, how will it be in the future? I don't know, but it will be very interesting. We're almost there. We're only 3 left for the AI to finish generating. Oh no, 40 left. Wow, just a little bit, like 33 left. Let's see something else. How many neural networks do you have inside of you? As an AI language model, I have multiple neural networks that work together to perform various tasks, such as natural language processing, speech recognition, image recognition, and more. Oh, he recognizes images. I didn't know that. These neural networks are constantly being updated and improved to provide better performance and accuracy. However, the exact number and details of these neural networks are not publicly available, as they are proprietary information owned by OpenAI, the company that developed and trained. Awesome. Let me ask something else. See, what is the most difficult task for you to do? As an AI language model, I am capable of performing a wide range of tasks, such as generating text, asking questions, performing language translation. However, there are certain tasks that can be more challenging for me than others, particularly those that involve complex reasoning or require deep understanding of context. As you can see, he speaks really well, no errors, no mistakes. It's very refined. There are no words that make no sense. Everything is understandable. It's pretty nice. For example, I may struggle with tasks that require me to understand sarcasm. I've always said that AIs can't understand sarcasm because it needs like a social context, more information that you need that the sentence alone doesn't have. So sarcasm, irony, or humor. Well, humor maybe can be done, maybe. But sarcasm and irony, pretty difficult, because how would an AI know that a sentence is not what it means in reality, but it's backwards, like in sarcasm or irony? So I think it's difficult. I need to investigate if it's possible. I've never been able to do it. It will be very interesting. Okay, I may also struggle with tasks that involve emotional or subjective responses, such as providing personalized advice or counseling. Despite these limitations, I am continually learning and improving through ongoing updates and training, which helps me to perform more complex tasks and handle a wider range of language use cases. Pretty cool, pretty interesting. Let's see. Okay, training successful. Awesome. Right now, then let's test. Perfect. Let's see if we can build a random message. It will take a long time, I guess, because of course this random generation is very different than the real way we speak, and it made something. Let's see. Wow. Update and boot pain. Now all country here now Georgia help support or help Ian impressed first. So as you can see right now, it doesn't make sense much, but at least you can see a real structure of the sentence and how each word relates to one another. So it's not a randomly arranged set of words, but you can see that each word relates to the other, and it has some how can I say that, like clarity, like it kinda makes sense what it says. Let's generate another one, and I think we will be fine for today. I really enjoyed this stream. It was a bit difficult because this is very innovative, but it's the more difficult, the more fun I have. So it's really, really nice. The more difficult it is, I think the bigger the challenge and the bigger the satisfaction when you manage to succeed. Okay. Who by aircraft New York very make country is as law in help slow and be far enough time job. This is the right-leaning message. Well, let me try. This is a left-leaning message. So let's see. Well, let me get another one. Okay. Let's see if this is correct. If this is a left-leaning message. This is another thing I wanted to test. If I add this, it also says left. No. So this AI, since it's trained with a really bad iteration quantity, it's not that accurate detecting the left or right. It's only 111 iteration. When I add this quantity, it's way better. It's way better, pretty accurate. So well, with this we are finished for today. I really like this streaming. It was really fun. I thank you for being here with me. I really like to create technology for you to test it, download it. Of course, I'm going to share it through GitHub. I'm going to upload a slightly improved version with some fixes and to make it faster. Of course, improving this system takes time. In the streaming, I take shortcuts and do things that sometimes make the process take longer when the AI works and trains. But yes, I will upload an improved version, and if you have any question, let me know. I will create a Discord chat as well, so we can connect there and chat, and also get recommendations from you. If you want to if you want me to make something that you have in mind, if you want me to create something like a video game, an app, or a new kind of AI, or if you need me to create something new that you want to understand, anything, I will be able to do it. I will create a Discord chat for that. And with that, well, I thank you for being here with me, and see you in the next episode of Guaire Dev Stream. Thank you, guys.